So Ramanan, tell me how the course started, how you and the ENV folks discussed this and what your aims were with the course.
So this course started essentially in the context of thinking about commons problems in health, which is essentially problems where individuals might act in ways that don't take into account what happens to the rest of society, much like climate change or pollution. And so I wanted to start a class that was going to think essentially about commons problems in infectious diseases. And those would involve obviously the disease dynamics, also economics and policy. And we planned a seminar course, this is probably about 5 or 6 years ago, with just about 12 or 14 students in the very first year. And it was a 3-hour, once-a-week seminar, essentially around a set of readings that were looking at commons problems like antibiotic resistance, like vaccination, like surveillance for infectious disease, because all of these involve commons or public goods. But then you came in and then you brought the entire disease modeling component in a much stronger way. So how do you think that has interacted with the economic stuff that we had to begin with?
So this has been a really great course. It's the best course I've taught anywhere, actually, in 4 universities and 2 continents, I think. And it was great because it was going really well when I came to it. And I think it's grown to around 50 students and maybe rising since then. And it's also now become one of the core science options in the Woodrow Wilson School under the new teaching regime. So it now looms much larger. And there are 2 things that I love about it, I think. One is that it brings together this very diverse bunch of students. I mean, you tend to see this in liberal arts anyway. As a Brit, that's kind of interesting. But as well as molecular biology and EB and econ students, there are quite a few engineers. There's the odd religion major, Slavic languages, and that mix is a lot of fun. And it also means they, hopefully not we, but no one's quite sure what's going on second to second, because it's economic theory a little plus epidemic theory, and then applications to policy. But it also is really great that you got that blend of kids, because the problems that we face here in disease, the threats of disease and global health, I mean, just like the problems of things like climate change, these kind of almost existential problems, antibiotic resistance and so on, can't be solved at one scale. So you cannot solve them just with the wonders, and I mean the wonders of molecular biology. You can't solve them with population dynamics. You need that to think about herd immunity, but you can't just do it with that. You also need social science and economics. You need demography, you need economics to deal with questions like vaccine refusal, and ultimately, actually, and that's been an interesting discussion, you need ethics. So you need the humanities, so you need the whole range, and I know that's a big deal with the ENV now, and it sort of fits in to the much bigger kind of philosophical goals of the ENV program. It was particularly cool this year, I think, I don't know if you'll agree, that we had this course in the fall during the development of the story of the meningitis B outbreak, because with the skills that the kids have learned from the 2 sides of the table of the epidemic stuff and the disease biology and the economics and social science, and a little bit about the ethics, we could discuss the need to vaccinate. We could discuss the role or not role in this case of herd immunity. We could discuss how individual incentives would feed back against what the population of students was going to do, and all the kids in the class were fanatically going to go out and recruit lots of people to get vaccinated, actually. So I don't know whether we can't do the experiment. I don't know if they made a difference, but that was a kind of extra frisson this year, I think.
No, I think it certainly is a fascinating class for all the reasons you mentioned, and I think a lot of kids who come to this are also pre-med, and but it's interesting because they think they're going to medical school and then they're going to be able to solve a lot of the world's health problems, and then they realize that a lot of global health has nothing to do with being a doctor. It has to do with understanding why people don't take their vaccines, or why they don't finish their course of treatment of antibiotics, why they overuse antibiotics, or disease modeling, how seasonality or mathematical functions can help us understand disease much better than just trying to deliver care to one patient at a time. So I hope that they take that with them, and that this really informs the kind of doctors that they really become. And many of them will possibly not become doctors, and they'll still have a profound impact on global health.